Hello, I'd like to welcome you to this presentation of the IHE. In this session, we are going to be looking at Code for Health, which is an effort to simplify and accelerate implementation. My name is Barry Reinhold. I'm the President and Chief Technology Officer of Lamprey Networks. Lamprey Networks has been brought in by the IHE to develop code and to ensure its continued progress in this area. All right, so let's get started. Code, the acronym for which stands is Continua Open Development Environment, is designed to address health issues and particularly to be able to provide commercial-ready software that implements a set of industry standards that are related to collection of personal health device data. This is an important aspect of where the health industry is going, because personal health data is often collected in home settings, and this data has a lot of pertinent information about where a person is and what they're doing in their normal context. So why did we go ahead and develop code? There exists a real significant deployment right now in homes of personal health devices. They're used all the time to collect health data and to collect fitness data. And as we move forward, we anticipate even more devices will be available in home settings. So the quality and breadth of the health information that is actually available in being collected is very large, but is not necessarily data that is easily consumable in the broader healthcare community. So we have this potential of a lot of information that we can find about people in their situations, but we do not have this access to this data in a way that can be used. And the core issue that is out there is that the way the data is collected, the way the data is represented, is not consistent and it's not trustable. So the overall broader healthcare industry can't take this data and put it into back-end systems to support decisions and to support analytics. There are many issues associated with legal concerns and just what does this data actually mean and can we trust it? Now, this is not a new issue, and standards have been developed over time, over the past 20 years actually, to address a number of these issues. But the core problem we have is that these standards are not being adopted by the broader industry. In part, this is due to the complexity. In part, it's due to awareness. In part, it's due to the cost of implementing these standards. They all hinder the adoption in the market. And so this potential that exists of a wealth of data to help us with our population health is not available in a way that we can actually take advantage of it. And code is an effort to address that problem. So specifically, what are the objectives of the Code for Health program? We want to unleash the potential of that data sitting in those personal health devices, because if you can get that data, you can really do a lot to improve population health. And code wants to remove some of those barriers with getting that data. And we can do that by providing the software components that are needed to deploy a personal health data system in a standards-based manner. The standards themselves are very confusing. And so what we really want to do in code is not make people understand standards, but just be able to take those standards in the form of code, a much more consumable input for many organizations that are going to be doing development work. In doing that, we also have to address a number of regulatory concerns that most software projects don't have to do. When you get into medical devices, these systems are very highly regulated. So code has to be able to provide the associated information with its history, with its development, with its validation, and the things that you might need to do to bring this software into a medical device and get regulatory approval. The other key thing of the code project is it wants to be in the open. So it wants to be a very controlled software development environment, but in an open context. So we anticipate distributing the software by an open repository and support that with the necessary documentation to make it something that is going to be commercially viable and ongoing. So that's a quick summary of what we're trying to achieve with in the Code for Health objective. And you can summarize that simply by saying, we are trying to make standards that will encourage the use of personal health devices available in a new form, and that new form is simply software that can be easily deployed in commercial environments. All right, to understand the next level of what code is, you sort of have to understand a little bit about what the architecture is like for collecting data from personal health devices. Personal health devices typically sit in a home context or in some context that is outside of the clinical environment. You need to take that data and you need to move it to the health and fitness server, to the electronic health records, to the places where clinical organizations are making decisions and using that data. Now, technologically, that's not very hard to do. I mean, we can move data from one location to another pretty simply, but the form and the regulatory concerns of the way you do that have a much bigger impact in this environment. So what has been developed over time is sort of this architecture that you see in the picture. On the left-hand side, you see the devices. Those devices need to generate data in a form that is understood. There's nomenclature codes and special coding systems by which the industry has gotten together and said very specifically what this type of code means. So we need those devices to generate the data with these codes. So the Code for Healthcare first objective is to be able to use those coding systems on the devices themselves when that data is generated. When that data is then moved to personal health gateways, and these are devices that will collect the data, which is typically communicated over Bluetooth low energy technologies or USB, things for people that, for close area contact or personal area network contact. These gateways take that data over Bluetooth, they convert it to a form, they address a series of regulatory concerns about personal health information, and then they upload that data to the health and fitness servers that are run by enterprise clinical organizations. And when they do that uploading of data, there's security concerns that have to be addressed, and there's standards that have to be met there also. So the code program also provides the software that would run on those personal health gateways and the software that's in those health and fitness servers to receive that. So the overall code program addresses the whole ecosystem of software that you see on the top thing. Now, there's some distinctive features about this software that I highlight here in this slide. The code program provides simulators to exercise both current devices as well as the potential of future devices that are being specified by standards. So instead of having all these different devices, you can use simulators that allow you to create the conditions or the information that the devices would typically generate and use them. This reduces the burden of collecting these devices and maintaining them and things of that nature. It also improves the ability for these devices to be integrated into test suites. So code also links proprietary devices into a standards-based ecosystem. On the personal health gateway, there's specific modules or drivers, if you want to look at it that way, that will allow these devices that are not standards-based to communicate the data to the gateway and then to translate that data to the extent possible into the standards form at the gateway. This provides an evolutionary path for some devices that are not yet ready to actually implement the specifications they need to on the device themselves. Yet it gets the data into the health and fitness servers where it can be used. So code is also designed to be a system that is meant to be used in a real commercial development processes. Now, those processes now are typically associated with cloud-based services. And so the code program provides a whole lot of tooling that allows rapid testing throughout that architecture of development, the details of which you can find in some of the links associated with this presentation. Some other distinctive items that you'd want to know about code is that it's standard software to simplify and accelerate adoption. And by standard software, what we mean is it implements all those standards that are associated with this overall process. And it's able to meet the regulatory concerns that you might have when you're going to take this device and get pre-market certification or the equivalent of it. The software also is experienced, meaning it has been involved in a number of interoperability tests, and it resolves a number of the common Bluetooth interoperability issues that typically come up when people put real devices with gateways and try to get these things to work together in a standards environment. There's also a specific cost advantage to some of the test platforms. You can buy a Bluetooth simulator for this thing for a very low cost by simply acquiring a pre-made kit for you. And that will help you to do these simulations without having to put the pieces together. Some of the other things that it's notable is it improves staff workflows, meaning that you can implement various common workflows that are associated with the collection of data. It streamlines regulatory approvals because there are the necessary technical files, and you can submit some of these technical files when you have to do pre-market certification and things like that. All right, let me get into some of the details that is now associated with the software itself. Now, a lot of this is just a little bit of checklist items, so bear with me as I go through this. But code covers medical devices, those things that were on the left-hand side of it, the gateways, the things that were in the middle, and the cloud-based servers and applications. So in other words, it's the whole ecosystem associated with collecting data for personal health devices and delivering that into the cloud. It also covers the set of standards associated with representing and exchanging personal health device data. That includes those things associated with the HL7, IHE, IEEE 11073 group, the Bluetooth SIG med device work groups, the IETF, and the guidelines from PCHA Continua. You can see there's a whole wide collection of standards that are associated with this process. They're all taken into account in the code program, and all those standards are implemented for you. So it's in a much more consumable form. Code allows you to quickly bring up an operating health and fitness server in the back end. And this is a very scalable server based on Kubernetes and Docker containers. So you have the infrastructure for a broadly scalable system. And that is probably critical if you are going to start servicing large number of medical devices out in the field. It provides a framework for integration of proprietary device data, which I've already mentioned. And there's a full validation framework, the outputs of which you can submit for your regulatory concerns. We move from what it covers into what the actual components available to you are. What we have is small C modules for common personal health devices. We have specific libraries that reside on Android and iOS for personal health gateways, the thing that was in the middle there in the diagram before. We have applications that also sit on Android and iOS personal health gateways. So we have not only the libraries that you can build your applications on, but we have applications that you can use to validate and to test and to see how the overall system should work, so that you can take those libraries and better, more easily make use of them. There's a complete demonstration gateway application that takes the device's data and moves it into the cloud. So you can take that and go to various plug fests and things of that nature where you might need to test your device and be able to use that to participate in those types of events. And there's Docker encapsulated modules on the back-end health and fitness server. In particular, there's a module that does the fire receiver component, which is one of the most commonly requested modules. The development environment for these software components include device simulators, includes test infrastructure, it addresses continuous integration. There's an actual test platform, which I had mentioned earlier. It's all available in an open development environment context. And we tend to bring this through connectathons, and we have the technical files that can support the submission, in particular the technical files that are often required by 62304. All right, so where are we at this point in time? There's an operational health and fitness server providing a file repository to which personal health data can be uploaded. So you can actually go ahead and play with that. It's a running thing out there in the internet. You can point your gateway or your device to that HNS server, and you can upload data to it and validate that the data is the proper form. There's release packages containing the health and fitness server build, plus different services and Docker containers. There's an implementation of ITU H812.fire, that's the Fire receiver component. There's an SDK for Android personal health gateways. It supports the Bluetooth Low Energy Manager. It supports the proprietary device driver plugin test framework and has examples. There's full test suites. There's Bluetooth simulators for common personal health devices. And where are we going with code as we move forward? This is not also just code, but it represents the direction IHE in the personal device area is taking. So one of the key things that is happening from a standards-based perspective is that there's still an effort to simplify the overall process of moving data through all these standards. And as that simplification is moving forward, it's taking place in two key groups. One is in the IEEE with the development of standard called 10206, and another in the Bluetooth generic health sensor. The code program is involved in these standard development efforts right now, where we are implementing these new developing standards, in part to help validate the standards themselves, but also to make this technology available as early as possible, so people can get their hands on this new generation of specifications, which do significantly reduce the complexity and the size of code bases necessary to perform the operation of the old standards. There's an IHE profile that is also in development for delivering health data directly to the cloud, and code is also involved in that process. All right. So how can you get involved with this program? I think probably one of the easiest things to do is to pull out the software and become involved in testing it. You can stand up your own Kubernetes cluster with code and validate the ability to upload observations to it. That will require some degree of software development. Obviously, you have to have the IT infrastructure and some of the background to be able to implement Kubernetes clusters. If you have that understanding, the tooling in code will make that pretty easy, but it does require a more technical background in some tasks. Implementers can build applications using the gateway SDKs. So you can get involved by actually taking the SDKs and implementing the applications on top of those SDKs, and provide comments, feedback, and other things associated with developing applications for gateways. You can simply test the demonstration application, provide feedback on that, and you can review the documentation that's out there for developers. And there's always the possibility that you're interested enough of this to be a funder or contributor to the work. So any of those ways are helpful to the overall code project, and we would encourage your involvement in that. There's a number of links below which will provide you the more exact details on how code works. There are videos that show run-throughs of the systems and the build procedures and walk through the documentation and things of that nature. So if you're interested, I encourage you to follow up by reading those. Thanks for your time, and we hope you are able to take advantage of code and help move personal health device data into the broader ecosystem in a standards-based way.